Okay, we are finishing up our lecture for Chapter 9 with the final module on hunger and weight regulation. So I want to introduce some of our key players or our characters that we're going to be talking about in terms of hunger and eating regulation. So glucose is important because it's our body's main fuel. We already talked about it in terms of the main fuel source in the brain, but it also is for the rest of our cells. We have other nutrients, but we're going to focus on the glucose today because the regulation mechanisms for it are a lot better understood than some for our other nutrients. We also have glucagon, which is a substance that helps us to get to that glucose. So we tend to, when we eat extra sugar, it's going to float around into our blood. Some of it's going to go in and feed the cells. Then there's too much floating around in the blood. So it will get converted into glycogen and stored on the liver temporarily. This is a temporary store. And eventually, if you have even too much to store in the liver, or you keep doing that long term, it gets stored as fat. So glycogen, which we don't have on here, is the form that glucose gets changed into when it's stored on the liver. And then glucagon is actually the substance that our pancreas secretes when we are hungry and we haven't eaten and we don't have glucose floating around in the blood to get into the cells. Our pancreas secretes glucagon, which goes and breaks down that glycogen into glucose off of the liver so that it can feed our cells. Now, glucose can't just passively transport into your cells. It can't just drift in there. It needs active transport. And the active transporter that gets it across the membranes into all of our cells is insulin. Insulin is also secreted by the pancreas. So the pancreas does this important job of moving sugar into our cells. And also, when there's not any sugar to move into the cells, burning that sugar off of the liver so that it's in the blood to move into the cells. So the pancreas is secreting both of these. It also helps us go the other way around and convert some of that glucose into storage. So insulin helps you to move the blood or the sugar that's circulating around in your blood into your cells. So when your cells get hungry, insulin can push glucose into them. Now for people with diabetes and type 2 diabetes, typically they have insulin resistance where they've been eating too much sugar over a lifetime. They've been secreting too much insulin to the point where their body doesn't even respond to it anymore because they've had such high levels over such a greater amount of time. So typically they have to take some other kind of drug to regulate their blood sugar, drastically change diet, and they also need to sometimes take insulin shots that will give them much, much higher levels of insulin, enough that their body can actually respond to it and move the glucose into the cells. For somebody with type 1 diabetes, their pancreas stops making insulin. The cells that do that die off, so they may stop making it altogether. It becomes pretty extreme. The body attacks its own cells. It's an autoimmune disease. And the cells that make your own insulin die off. So you have to have insulin from elsewhere, or else your cells will starve. There will be sugar just circulating around in your blood that can't get into any of your cells. Your cells will starve to death just seeing all that sugar through the window and being unable to access any of it. So we take for granted, those of us who don't have any problems with our pancreas, the jobs that insulin and glucagon do for us constantly. They play a role in us feeling hungry and satisfied, though that does depend on the circumstances. CCK stands for cholecystokinin, and this is a molecule that it's a hormone that allows us to feel full. It does this in a few different ways. So one of the ways that we feel full is just by stretch receptors in the stomach saying, hey, the stomach is stretched out, so it's probably full. And then that triggers cholecystokinin to be released as well. So specifically, cholecystokinin actually is released from the cells in the duodenum, which is the first part of your small intestine. It's the first bit of intestine right below your stomach. And so it will notice that you're getting kind of full, and CCK will actually um, make you feel even fuller to get you to stop eating. So the cells in the duodenum will detect that you're getting full. They will start to constrict this sphincter that connects the stomach to the duodenum and tighten it up so that your stomach feels even more full. So it's especially saying, stop eating, you're good. Does this in the body so you physically feel fuller, but then it also sends a shorter version of CCK to get released in the brain that is small enough to cross the blood-brain barrier to trigger areas in your hypothalamus to get you to stop eating. So we actually have lots of mechanisms that help us do this, to eat or to stop eating, but the ones that get us to eat tend to be stronger, because if you think about it, more of our ancestors dealt with starvation than they did with obesity being a serious health threat. So we have a lot more backup systems to make sure we stay hungry than to make sure that we stay full. Ghrelin is one of those backup systems to make sure that you stay hungry. It's our major hunger hormone. There's a disorder in which people have too much ghrelin, about 5 times the normal amount, and they will just feel like they're starving to death constantly and eat themselves into morbid obesity even from a very, very young age. So if you've seen pictures, or if you've seen, a child on Maury Povich or something that's, already a couple 100 pounds around an elementary school age, it could be that they have this Prader-Willi syndrome in which they have too much ghrelin and they're constantly hungry. On the other hand, we have a fullness hormone that works on a more longer term. Leptin is secreted actually by adipose cells, which is our fat cells. Leptin says, we already have enough extra stuff stored away, so maybe we can cool it. We're not going to be as hungry. It's going to be fine. So leptin is triggered sort of like when bears are going to hibernate, right? Because they have stored back enough fat, and at some point they need to stop eating so they can go to sleep, so that they don't wake up and feel hungry constantly during hibernation. Leptin's there, just being secreted by those fat cells, saying, okay, you're good, we have enough storage, until towards the end of winter when they've already slept and like burned off enough of that fat. There's not enough to secrete enough leptin anymore. And then ghrelin starts to come back. So they start to get hungry, get up and move around and search for food. You might ask yourself, okay, if leptin comes from fat cells and it tells us that we're full, could leptin be used for weight loss? And people have thought this in the past. Could CCK be used for weight loss? It's another thing that helps us to feel full. Part of the issue with CCK is that it mostly has to do with that sensation of stomach fullness, and most people who have any kind of um, struggles with being overweight or obese generally have learned to ignore these signals. So really behavioral training of learning to mindfully become more in touch with the signals that your body gives you about hunger and fullness is probably better than trying to pump more CCK into people, because they already have plenty of CCK and they have learned to ignore it. And I say they, but I really mean we, even people who don't consider their weight to be a struggle. Most of us have been taught to eat when food is in front of you and to clean your plate, even if you're not hungry anymore, right? So we're good at ignoring fullness. Leptin is kind of similar. It is a longer term one, but we've noticed that most people who are obese have plenty of leptin. Their fat cells are working just like any other fat cells and releasing leptin constantly. But again, they're not sensitive to the signals that leptin is sending. So even giving leptin to obese mice, for example, they tend to be sort of leptin resistant, sort of like how people with type 2 diabetes are insulin resistant. So again, treating through behavioral training tends to be more effective. We're going to talk a lot more about weight loss on our final slide, but let's move into glucose regulation, which I already mentioned. So when we have high blood glucose from eating a sweet meal or from eating a high carb meal that gets quickly broken down into sugars, our pancreas detects this high amount of sugar floating around in the blood, and it releases insulin from our beta cells in the pancreas. So these beta cells are the ones that when you have type 1 diabetes, your body attacks and kills off. So insulin is released by these beta cells, and then, well, fat cells, but also any of your body cells, to be honest with you. I'm not sure why this just says fat cells. Your body cells take in glucose from the blood. If you have a lot of glucose, yeah, eventually your fat cells are going to be fed to store this up. But it's this negative feedback system, just like with our body temperature, that helps us to achieve this homeostatic normal level of blood glucose levels. When you have low blood glucose, your pancreas notices this as well, and it releases glucagon from alpha cells in the pancreas. So your alpha cells may not be as affected if you have type 1 diabetes. Sometimes they are, so you'll find that people with severe diabetes can have dangerous blood sugar lows, and they don't have this process of getting the glucose off of their liver as easily. So they need to take glucagon tablets or drink a little bit of juice or quickly eat a candy bar or something really sweet to get their blood sugar back up, because their body is also not doing this process as well. So again, when the blood sugar is low, your pancreas secretes glucagon that gets this glycogen off of the liver into glucose, and the glucose is now in the blood, and now you have a normal blood glucose level. So it's not really so much that you need a certain amount of sugar in your blood. So having low sugar in your blood is really not, the only reason that's a problem is because your cells can't get fed, right? If there's normally insulin is here to move the sugar from your blood into your cells. So when you have low blood glucose, you will also have insulin released somewhat, usually if you're expecting a meal. Insulin might get released, but there's no fuel to move into the cells. So it's really all about making sure our cells can get fed. So when you have high blood sugar, your cells are hungry. They're looking through the window at all that food and saying, insulin, come here and move this, move this sugar through the door so I can get to it. When you have diabetes and this insulin is not moving the glucose into your cells well enough, again, those cells are going to starve. So they're going to be hungry. Even though you have fuel, you have eaten, you can eat and eat and eat, and it doesn't go anywhere. So unexplained weight loss is one symptom of diabetes, because your body is slowly starving, actually, if insulin is not moving the glucose into the cells. And maybe you're like, oh, what if that was a cool weight loss technique? Well, okay, that's kind of messed up thinking, first of all. Second off, it's bad to have too much sugar in your blood because we know that a lot of pathogens feed on sugar. This is why it's extremely dangerous for people with diabetes to get injuries, because if they have a cut, they're far more vulnerable to infection because their blood is so sweet. All these pathogens are going to want to feed on it. So this is why you can easily chronically keep thrush or yeast infections, fungal infections, especially anywhere in the body, are common. So even like your athlete's foot type stuff is very common in diabetes. This is why one of the complications can be amputations eventually in this disease, because infections can become so difficult to treat and so persistent. Now, on the other hand, when you have low blood glucose, you will also feel hungry. Your cells are hungry and they're saying, okay, let's look in the blood, and there's no food out there. Oh my gosh, what are we going to do? So if you don't have glucagon to get that glycogen off of your liver, your cells are also going to starve. So your pancreas is helping to prevent these two very different ways that your cells can starve to death. So they can starve because there's just no fuel around. They can also starve because there's fuel there and they just can't get it into the cells. So this is why having blood sugar highs and lows can actually feel kind of similar in terms of symptoms. Many of us might have experienced what it feels like to have low or high blood sugar. We just don't experience it to the same frequency and degree that people with diabetes do. But a lot of people nowadays have this problem of hypoglycemia. For many of us, it might stem actually from allostasis. So we typically have high carb, high sugar meals, and our body learns to expect these high levels of glucose. So before you even eat and your body, your pancreas detects high sugar, it's saying like, look at that, look at all these carbs, you're about to get some high sugar, so I'm going to go ahead and secrete some of my insulin to make sure when that sugar rush hits, we can rush it into the cells and you'll be good. So let's say that you just saw that food, like maybe you're at work working at a restaurant, you just see this food, but you can't eat it because you're still working. You're missing this shift. So your body's like, oh boy, we're about to get these high carbs. Here's all your insulin. And you don't get to eat for still a couple of hours. You're going to feel this awful crash because your body's like, all right, going to move the insulin into the cells. Or you're going to use our insulin, all this insulin floating around now to move all the sugar into the cell. Right, where's the sugar? So now suddenly you're going to have a low blood sugar when it was before you entered the cycle, it was normal. You're going to feel shaky, headachy, irritable, and you would need a high amount of sugar for that high amount of insulin to do you any good. You need to move a crap ton of sugar into your cells. And so this cycle continues. Your body learns to anticipate the amount of carbs and sugar that you typically eat, and it releases a commensurate amount of insulin. So we all typically release insulin before we eat. And people with diabetes, when they have to self-administer insulin, they need to learn to do this on a particular schedule. So you need to give yourself a shot 20 or 30 minutes before you're going to eat, so that the insulin is definitely there, so your blood sugar doesn't get high. So when the sugar hits, you can move it into your cells. But this can be dangerous. You can imagine somebody with diabetes could have this awful cycle of hypoglycemia if they give themselves a shot because they're going to eat a big carby meal, but then there's a long wait at the restaurant. And they don't get the meal on time, and they have a bunch of insulin in their blood sugar drops, they feel like crap, and they're craving even more sugar. So typically this is why you need to have, when you have diabetes, have some emergency sugar on you. And so you're not finding yourself digging through the sugar packets on the table and making your tea really sweet or something. Now, as I mentioned before, we are really good at putting on weight. That's what our bodies are designed to do. So give yourself a pat on the back and say, like, thanks, body, for making sure that I'm not going to starve, even though I'm no longer living in an environment of starvation. A lot of diets are popular nowadays that try to focus on how our ancestors ate. But to be honest with you, our ancestors ate basically everything in sight whenever they could, because they didn't know when they were going to get it again. Think about fruit ripening. I mean, it's only available for like a couple of weeks. Get it while you can, right? You're going to gather and eat everything you possibly can because you don't have refrigeration. You can't freeze the fruit or whatever. I guess you can dry it, but like, get it while you can. Eat all those figs, all those grapes. Get it now. So we're actually programmed to kind of just find calories wherever we can get it and eat the sweetest, like most high calorie stuff we possibly can. So the paleo diet wouldn't be like trying to avoid sugar and this kind of stuff. Like, we are still caveman bodies, and the way we eat is by getting all the freaking sugar that we can. Now, I want to take a moment to address the dieting mindset that puts people in some disordered cycles, even if they don't have an eating disorder. These types of cycles make dieting dangerous. So people have high standards for themselves, very ridiculous restrictions to adhere to, and they feel like they're being a good person, like they're morally correct when they can follow this diet. They're better than you, or better than they used to be. But then they have a really bad day where they get stressed out, so then they blow the diet. And then they get these feelings of guilt and shame, and what do they do with feelings of guilt and shame? Well, they might eat more or they might diet more and put themselves back into this cycle. So we live in a culture that thinks about our health and our hunger and fullness and weight in kind of messed up ways where we need to try to compensate for it. And that can put you straight into this cycle. If you're like, I need to walk off that cupcake, that's sort of like a milder version of being in this cycle. So what many nutritionists and dietitians will tell you nowadays is not to be on any kind of special diet of any kind. So if you're doing paleo, keto, blah, 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 I'm going to go ahead and tell you it's a flavor of the week and it's garbage, just like any other diet. The 5 foods you should never eat are rotten food, poisonous food, foods that you don't like, foods that you are allergic to or make your body feel bad in some way, or food that you don't want but people are just trying to give you. Simply because people are telling you to eat. Instead, notice your hunger and fullness cues. And when you start to do this, you will notice that you will feel how those high carb meals tend to make you feel like crap, right? And you might try eating a lot more vegetables. You will become a lot more in tune with noticing your fullness cues, with how full your stomach feels, and knowing that that's time to stop eating, maybe even before then. Um, as I've mentioned before, humans are really good at putting on weight. We tend to do this over the holidays a lot, and a lot of people think it's because, well, we have holidays that involve eating a lot. We got Halloween and Thanksgiving and Christmas and New Year all within a very short period of time. New Year tends to have that added bonus of binge drinking, which tends to change our eating drastically. And then we have this idea of strictly dieting and working out with the new year to try to get ourselves back into shape or whatever. And again, it tends to put us in this kind of cycle. This is why New Year's resolutions don't work. You make it too strict and make your expectations unreasonable for yourself. So a lot of people say, yeah, it's because of these holidays that we gain weight in the fall. But I would encourage you to think of, why do we have holidays that involve food at these times of year in the first place? Could have to do with a circannual rhythm of weight regulation in which our ancestors might have benefited by putting on weight in the fall so they could get through the winter. So we have all these nice harvest holidays that are sort of designed to do that for us. So in order to stay healthier during the holidays, make healthy choices like you normally would. So eat, a few normal sized meals, have fiber and protein and lots of water, and that kind of stuff helps you to feel full. And you can choose what to eat. So you can have tiny amounts of everything, or if you don't have room for trying everything, you could ask, hey, do you mind if I pack up a little bit of that and take it home with me? It looks delicious. You don't have to eat stuff just because it's there. Now that we talked a little bit about normal and disordered eating, I want to talk some about weight loss and our expectations for it. So a lot of weight loss that's dramatic in terms of losing large amounts of weight is very, very, very difficult to sustain. Part of that reason is because people have unrealistic expectations. They expect to be like the biggest loser and lose 200 pounds, and then keep it off and look like a celebrity after that. Another thing we fail to understand about weight is set point theory. So just like your body temperature and your solutes have set points that they need to stay within, body size and fat composition may as well. So you may have a set point for the amount of fat that you have stored. And your set point may have been dialed up or down early in life depending on your experiences. Some of it could be genetic, some of it could be based on you got wired differently due to, childhood obesity or something like that. So your body's going to try to put you back in that set point, really no matter what you do, within reason. What I mean by this is we probably know those people who are thin and can, even if they're not very active, they can eat whatever they want and their body size doesn't change because their body is taking a different proportion of that to burn and a different proportion to put away as fat at different speeds. Um, and then we know those people who, gain weight at the drop of a hat and can't seem to ever quite get it off. Or if they lose some, they come back up. And over time, I've discovered my body's set point where I've noticed, oh, if I'm making healthy choices and not feeling like I'm restricting or completely out of control, eating everything in sight, my body has a certain middle point where it stays. Um, Many people have this as well. So when people become obese early in life, their set point tends to get dialed up. And we find that even if, like in mouse studies, you have an obese mouse, you give it liposuction or you just straight up surgically remove its fat, even if you restrict its diet, it will still gain the weight back. Yeah, that's how intense this set point for body size is. So, um, we need to slowly, if someone needs to lose a very large amount of weight for health reasons, they need to slowly do it and become comfortable and expect that they're going to have plateaus. So lose 10 pounds here in a couple of 3 months, and then probably not lose any for 4 to 8 weeks, maintaining the healthier choices that they've made while their body gets used to, okay, this lower weight that's 10 or 30 pounds lower or whatever is my new set point. And then if they still need to lose more, they can go through that plateau process, losing some and then having a plateau process again. So what we tend to encourage nowadays, instead of dramatic dieting or anything else, is making healthier choices. You can make healthier choices without being obsessed with the number on the scale as the most important metric, because it's really not. The reason the number on the scale matters is because in the long term, it can snowball into causing other health problems or making some of them worse. But in the short term, being a different body type or size is actually not particularly harmful. So you have the time to take it slow. You only have to lose about 10% of your body weight, even if you're morbidly obese, to dramatically start to reduce your health risks later in life. So it doesn't have to be like The Biggest Loser. And I think our biggest struggle with weight loss is not just that it's difficult to lose weight, but really that it's difficult for us to understand how weight loss and set theory work, because that is at odds with everything that we see and think that we, aspire to look like, or think that this should work for us. So please don't follow Beyonce's new 22-day diet, okay? It's garbage. And you really shouldn't be dieting unless a doctor has told you that you need to lose weight. And even then, some doctors can still be wrong about that. So I encourage you to, if you are a yo-yo dieter, if you eat a little bit less, eat more vegetables, work out more, get enough sleep. If you do those things without ever stepping on a scale, you're doing your body good things. Okay? It shouldn't be about, swimsuit season or fitting into your bikini or something like that. So I encourage you to think about this differently, because those smaller changes are more sustainable over a lifetime. They're just not as flashy for like magazine covers, or like, they don't make you money on Instagram. And that is all we have for today's lecture on internal regulation. Thanks, folks, and I hope to see you soon.